Let's practice graphing quadratic functions that are written in standard form together. Remember, quadratic functions that are written in standard form are going to take this form of f of x is equal to ax squared plus bx plus c. And while there's other forms of quadratics, when you graph them, they're going to create these parabolic shapes or parabolas. So they can either open up like this, or they can open down like this, at least for the purposes of this video. Throughout each of these practice problems, let's go ahead and create a table together of x and y values. Then we're going to go ahead and graph each of these quadratic functions. And finally, we'll label the vertex and the axis of symmetry for each of them as well. If you'd like to download this PDF for free, check out the description box below where you can find a link for that. And there, hopefully you'll find a bunch of other free resources that might be helpful to you or someone you know. Let's jump into number one. For number one, we have f of x is equal to x squared plus 3x plus 2. And the first thing I'd like to do is just identify what our a, b, and c are. A is going to equal 1, b is going to equal 3, and then c is going to equal this positive 2. So we're just going to go ahead and label that just so we know what they are. So a equals 1, b equals 3, and c equals positive 2. We can use this information to figure out some more stuff about this graph. Now it's important to note that quadratic functions or parabolas are symmetrical. So they're going to be symmetrical about this line called the axis of symmetry, and I'm going to abbreviate that as the AOS for this video. Okay, so there's actually a formula we can use for this, and if you'd like to see a proof for that, I can do that in another video. But for the AOS, the axis of symmetry, the equation is going to be a vertical line, so x equals, and the formula is going to be negative b, or the opposite of b, over 2a. Okay, so if we use this formula, we can get the equation of a vertical line, which represents the axis of symmetry. So let's go ahead and do that first. X would equal the opposite of b. So the opposite of b is going to be negative 3 over 2 times whatever a is. That's going to be 2 times 1. And so 2 times 1 is going to still be 2. So that's going to be negative 3 over 2. And so that's going to be our axis of symmetry. X equals negative 3/2. And the reason why we want to start with this AOS is because that's going to let us know where the middle of this parabola is, and we can always put the AOS located in the center of our table. And before we go any further, I'm just going to start sketching an XY plane and label where the axis of symmetry is so we know generally where the graph is located. Alright, so there's our XY plane. And let's go ahead and label where x equals negative 1 and x equals negative 2 to start. And we know that our axis of symmetry is x equals negative 3 over 2, which is 1.5. So let's go ahead and draw our axis of symmetry, or a vertical line that kind of divides our parabola in half now. So our AOS, or axis of symmetry, is going to be located right around here, where it's going to be x equals negative 3/2, or negative 1.5. Now that we know where the parabola is going to be centered, we can go ahead and find out the vertex, right? So remember, the vertex is going to be the point that's located in the very center of our table. That's going to keep things nice and symmetrical. So let's go ahead and find the function of negative 3 over 2. So f of negative 3 over 2, that should tell us what our y value is. So we can go ahead and plug that in. So that's going to be negative 3 over 2, and we're going to square that, plus 3 multiplied by this negative 3 over 2, and then we're going to go ahead and add 2 at the end. Okay, so if we go ahead and find out what f of this value is, if you square negative 3/2, that's going to be positive 9 over 4. And then if we multiply 3 by negative 3 over 2, that's going to be adding a negative 9 over 2. And then if we're adding 2 at the end, keep in mind that as a fraction, that's just 2 over 1. If we get some common denominators here, this is going to be 9 over 4. Take away, if you multiply this by 2 and 2, top and bottom, that's going to be 18 over 4. And then multiplying top and bottom by 4 and 4, that's going to be 8 over 4. Okay, so if we take 9, take away 18, that's going to be negative 9. Negative 9 plus 8 is going to be negative 1. So it's going to be negative 1/4. So when x is equal to negative 3 over 2, y is going to equal negative 1/4. So now that we know the x and the y value of one point on this graph here, we can notice that if this is negative 1 along the y-axis, then where is this negative 1/4? That can be located along the axis of symmetry, maybe right around here. I think this kind of makes sense. It's right below the x-axis. Next, what we're going to do is we are going to just plug in some x values that are equidistant from our AOS value. So again, our AOS is this negative 3 over 2, or negative 1.5. If we go half a step smaller, half a unit smaller, smaller than negative 1.5 is going to be negative 2. And if we go the same distance positive, if we go up a half, that's going to be -1. Again, -3 halves is sandwiched between these. What's nice about choosing numbers that are the same distance from this -3/2 is that the y value for both of these are going to match because parabolas are symmetrical. Okay, so I'm going to go ahead and plug in either one of these into the function to figure out what the y value is going to be, and then we're just going to copy and paste that for the other one. So let's go ahead and figure out what I'm going to use this -1. Plug in -1 into the function. F of -1 is going to be -1 squared plus 3 times -1 plus 2. So then -1 squared is going to be 1. 3 times -1 is -3. So we're going to take away 3 and then add 2. And then 1 minus 3 is going to be -2 plus 2 is 0. So if -1 goes in for x, then y is 0. And then that's going to be the same thing for when x is -2. Okay, so we can go ahead and plug in those points and plot them on the graph. You're going to have one here and one over here. Okay, and they are symmetrical, so that hopefully makes sense. And then we can go ahead and plug in one more set of points here so that we get a third, one away from the AOS or going in both directions. So we can go and try something like -3 and 0. So again, keep them equidistant, going up 1 and down 1. And I think I'm going to plug in 0. You can choose, but I think 0 is easier to do. So if we find f of 0, right, then just x is going to become 0. So that's going to be 0 squared plus 3 times 0 plus 2. And so all of that is just going to become 0 plus 0 plus 2. And that just SimpLEEfies down to 2. So that's going to be 2 here, and that's going to be 2 here. All right, so going ahead and plotting these points, we do got to mark where -3 is located. That's over here. And then I got to mark where +1 and +2. And I guess I can mark where +3 is roughly. So just kind of approximating, not using formal graph paper or anything like that. 0, 2 is located along the y-axis. That's also the y-intercept. So in the future, notice that whatever constant you have here is going to match the y-intercept as well. As for -3, 2, that's going to be located right around here on the other side of the AOS. And so we have here 5 points that we can use to make a graph. At this point, just go ahead and draw a rough sketch through each of these points, and you should get something that looks like a parabola, kind of something like this. So that's as accurately I can maybe make it as possible right now. All right, let's check out number 2. For number 2, we have this f of x is equal to 2x squared minus 8x plus 6. So notice what our a, b, and c are here. So we have a is going to equal 2, b is going to equal this -8, and then c is this +6. So I'm going to write that down. A equals 2, b equals -8, and then c equals +6. Okay. So just like in that first practice problem, we're going to start with finding the AOS. So the AOS, remember, is going to be x equals the -b, opposite of b, over 2a. So we can use that to find out that middle line. So what is b? B is -8, so we're going to have the opposite of 8, which is just going to be 8. And then 2a is going to be 2 times 2. And so if we go ahead and simplify this, this is going to be 8 over 4, also known as 2. So what's our AOS? Our AOS is going to be x equals 2, and that's going to be where the middle line is going to be. So we know x equals 2 is going to be right in the middle here. Okay. Now that we know that, we're going to go ahead and see if we can find out the vertex, right? So the vertex is also located where the AOS is. We just have to find the y value. So let's go ahead and see if we can do that. For the vertex, we can go ahead and say f of 2 will tell us where the vertex is. So f of 2 is going to be 2 times this 2 squared minus 8 times 2 plus 6. Okay, so let's see what that's going to be. 2 times 2 squared, that's going to be 2 multiplied by 4 minus 8 times 2, which is 16 plus 6. And then so that's going to be 8 minus 16 plus 6. 8 take away 16 is -8 plus 6 is going to be -2. All right, so when we said f of 2, we found out that the y value, or f of 2, is going to be -2. So that's going to be the vertex. It's going to be 2, -2. So now that we know the vertex and the AOS, let's go ahead and start mapping out our graph a little bit. Here's our x and our y axis, and then let's go ahead and plot where 2 is going to be over along the x-axis, and where -2 is going to be located along the y-axis. We already found out that our vertex was at 2, -2, which is over here in quadrant 4, so we can go ahead and plot that one down. And our AOS of x equals +2 is going to be located somewhere around here. Now that we know where our AOS is, we can go ahead and pick some values for x that are equidistant from 2. So if we go 1 smaller, we go with 1. If we go 1 bigger, we go with 3. And again, whatever we get for the y values for one of these, it'll match for the other as well. So I feel like using maybe the 1. I think that might work a little bit better for me. So I'm going to say f of 1 into this function is going to equal 2 times the 1 squared minus 8 times the 1 plus 6. All right. And so what's going to be 1 squared? That's 1 times 2 is 2. So we have 2 minus 8 because 8 times 1 is 8, and then plus 6. And so 2 minus 8 is -6 plus 6 is 0. So when x is 1, y would be 0, and that would be the same when x is 3, y would also be equal to 0. So try to be strategic with choosing your values because it's going to make your life a little bit easier. So plotting 1, 0, that's going to be located right here. It's actually one of the x-intercepts. And then for plotting 3, 0, let's go ahead and just put one more line over here for where 3 would be. And I'm not going to write the number just because it's going to get a little messy. So here's where 3, 0 would be located. Okay. Following that, let's go ahead and choose 2 more values. So with that, let's go ahead and find out just one more pair. So let's go 1 smaller and 1 bigger. And so we have x equals 0 and x equals 4. And we can go ahead and plug in either one of these into the function. I'm going to use 0 because I think that's going to be a lot easier. And so let's see, if we go f of 0, that's going to end up being 2 times 0 squared minus 8 times 0 plus 6. So 2 times 0 squared is 0, 2 times 0 is 0, 8 minus 0 is 0, plus 6. So this whole thing is going to cancel out to just making 6. And so when x is 0, then y would be 6. And then when x is 4, y is also 6. Okay, so let's go ahead and plot these down on the graph. So here would be maybe 1, and 2, and 3, and 4, and 5, and 6 roughly. All right, just approximating, it's not perfect. So 0, 6 would be located somewhere up here. And where would 4, 6 be? I think we need to go a little further. So that's 3. This would be 4. And so 4, 6 would be located somewhere up here. Okay, so it looks like these are symmetrical, which is good. And we can go ahead and try to draw a graph or a parabola through these points. So some rough sketch that looks something like this. Again, try to go through the points the best you can and make it as accurate as possible. I'm getting something that looks like this. Let's try number 3. For number 3, we have this function f of x is equal to 3x squared minus 6x plus 4. So identifying our a, b, and c, we have a is going to be this 3, b is -6, and c is +4. So we're going to use that information. A is 3, b is -6. We can use those two for our AOS. And the fact that c equals 4 actually tells us our y-intercept. So you can use that if you'd like to, but it can be a little bit more helpful. Okay. For the AOS, let's jump into it. Let's go and see AOS. What's the formula again? If you can memorize it, great. If not, go ahead and just check what we did before. So it's -b over 2a. Okay. And so let's see what that's going to be. So x is going to equal -b. So -6 is just +6. And then 2a, 2 times 3. Oh, that's kind of nice. So 2 times 3 is 6. So 6 over 6, that equals 1. So x equals +1 is going to be our vertical line. That's going to be our AOS. So that's going to be the center of our table. All right. Let's go ahead and now find the vertex. So for the vertex, that's going to be when you find f of this value, right? The function of it. So let's go ahead and find f of 1. So f of 1, that's going to be 3 times 1 squared, just plugging it into the function, minus 6 times this 1, and then adding 4. So let's see, 3 times 1 squared is 1, times 3 is 3, 6 times 1 is going to be 6, and then plus 4. 3 minus 6 is -3, plus 4 is going to be +1, I believe. Okay, so we have a vertex here of 1, 1. Okay, now that we have that, let's just start sketching our graph so we know where things are. So let's go ahead and plot our vertex. So we know it's going to be 1, 1. That's located in quadrant 1 over here. So moving over to the right and then moving up, we can go ahead and plot that one point here. Okay. And then if we take a look at our AOS, which is the x value, that's going to be this vertical line. So it's going to look something like this. Okay, so we can go ahead and plot that. I think we can move this over just a little bit to the left. That's better. And that would be our AOS. Now that we have our center line, let's just go equidistant from the 1. And so I'm going to go 1 smaller and 1 bigger. So I'll pick 0 and 2 here. Okay, and you can choose either one you want to plug in. I think 0 makes more sense here, and we should just get 4 out because when x is 0, everything's going to cancel out. But let's go ahead and just show that anyway. So it's going to be f of 0. That's going to be 3 times 0 squared minus 6 times 0, 6 times 0 like that, and then plus 4. Okay. 3 times 0 squared is just going to be 0 minus 6 times 0, which is still 0, plus 4. We could have predicted this, hopefully. And then we're just going to end up with 4 for the y value. Okay, so when x is 0, y is 4, which was the c value from the beginning. And so then 2 comma 4. Okay, so we can go ahead and plot these down. So 0 comma 4, so we have 1, this is 2, this is 3, and here is 4. Okay, here was 1. And then we also are going to be able to plot down 2 comma that 4. So here is 2. And so let's go ahead and plot these down. So 0, 4 is up here. And then 2 comma 4 is right up here. Okay, now that we have those, let's go ahead and do the final pairs. Let's do -1. Let's go a little smaller, and let's go with 3, which is going to be a little bit bigger here. Just to stay away from negative numbers, I'm going to use the 3. So that's going to be your preference. If you want to use the -1, go for it. So let's do f of 3. F of 3 should equal 3 times 3 squared minus 6 times 3 plus 4. So 3 times 3 squared. 3 squared is 9, times 3 is 27, and then 6 times 3 is 18, and then plus 4. 27 minus 18 is 9. 9 plus 4 is going to be 13. So I'm not going to be able to fit these on here, but I think you kind of get the point that you can go ahead and if you had more graph paper or you scaled your graph a little differently, then you would be able to plot these down. So now that we have 5 points for our parabola, that's pretty good for sketching a graph. Now I'm not going to be able to fit that 13 on there, so I'm just going to leave mine like this and just plot these 3. But imagine if I had more graph paper or I scaled this a little better, I could have plotted all 5 points. But I think you get the picture hopefully. But these are with the 3 dots that we had that fit on my graph. Here's number 4. For number 4, we have f of x is equal to this 2/3 x squared minus 3x plus 6. Okay, so our a, b, and c, a is going to be this fraction of 2/3, and then our b is going to be -3, and then c is going to equal +6. All right, so let's start with the AOS as usual, and so our AOS is going to be x equals -b over 2a. Hopefully that's going to stick as you practice a little bit more. And so let's go ahead and plug in some values here. -b is -3, which just becomes +3 over 2a. That becomes 2 times this 2/3. That's what a is. And so that's going to be 3 over, what's 2 times 2/3? 2 times 2/3 is just going to be 4/3. So if we go ahead and divide this, this would be 3 divided by 4/3, which is the same thing as times 3/4, right? So 3 times 3/4 is going to be 9/4. And so if you write that as a mixed number, then x equals, I believe 2 1/4 should be our AOS. So 2 1/4. So now that we know where our AOS is, we can go ahead and find out our vertex. So not the nicest numbers, totally get that. But hopefully your fraction game is okay, and then you can feel pretty good about this. Going ahead and plugging in just a little bit of pre-algebra here. So order of operations, f of 2 1/4, that's going to be plugged into the function. So that's going to be 2/3 times, and actually maybe let's just write it at the improper version because we're going to have to do that anyway. So let's do 9 over 4 squared minus 3 times this 9 over 4. And then plus 6. Because we're dealing with fractions, I'm just going to write the 6 as 6 over 1 and then deal with, making common denominators in a little bit. So if we go ahead and evaluate a little bit of this at a time, 9 over 4 squared is going to be 81 over 16. And then minus this 3 times 9 over 4, that's going to be 27 over 4. And then we have plus 6 over 1, so I'm just going to leave that as 6 over 1. If we're going ahead and multiplying this first one, I think we can cross cancel. That's a 1 and that's an 8, and that's a 1 and that's a 27, if I'm not mistaken. And so we should end up here with 27 over 8 minus, instead of writing 27 over 4, let's multiply top and bottom by 2, and that would be 54 over 8. So we have common denominators. And then for 6 over 1, let's multiply that by 8 over 8, and that would be 48 over 8. So we have common denominators of 8 all the way across. If we go ahead and say 27 minus 54, that's negative 27, and negative 27 plus 48 should be 21. So I'm thinking 21 over 8, which is the same thing as 2 5/8. All right, so I'm gonna go ahead and write that's gonna be our vertex. 2 5/8 would be the y coordinate for the vertex. So that's the vertex for number 4. Keep in mind, the process hopefully still felt the same even though we had some annoying fractions. So sorry about that, but it's rather good to practice or review these together. So hopefully you feel better about it in the future. Now let's go ahead and start sketching the graph now that we know generally where the graph is going to be centered around. Now that we know the vertex, let's go ahead and start sketching out where the graph's going to be. So there's our XY axis, and let's go ahead and plot where 1 is, and then 2 is, and then maybe 3 and 4, just to kind of get things started here. And then going up the Y axis, let's go ahead and plot, maybe this is 1, this will be 2, this will be 3. I don't think I'm gonna be able to fit all 5 points on here, but I'll just go ahead and put these for now, and we'll see how many we can fit. Hopefully we can fit 3 of them on here, okay. So the vertex is 2 1/4, comma 2 5/8. So 2 1/4 to the right, and then 2 5/8. That's 2 5/8 is a little bit more than 2 1/2. So I'm gonna put a dot right around here. All right, so just again, mine's more of a rough sketch. If you have graph paper, yours is definitely gonna be more accurate than mine. So now that we have this one, let's go ahead and put our AOS on here. So I think that's gonna look something like this. Let's see if I need to move it over just a little bit. Again, I think that's roughly 1/4. I know it's not perfect, but here is where 2 1/4 I think would be roughly, okay? And so now we know the center. So let's go ahead and plot some points, and let's pick a number. Let's go, I'm gonna go 1/4 less than this. So 1/4 less than 2 1/4 would just be 2, and then 1/4 more would be 2 1/2, okay? And so while you might think like, oh, why would you use 2 1/2? Well, again, we don't have to use that one when we're plugging it in. Let's just use 2, and then we know the y value for 2 1/2 also. So don't worry about doing extra fractions if you don't have to. Let's go ahead and plug this in. This would be f of 2 into the function. F of 2 is going to be 2/3 multiplied by 2 squared minus 3 times 2, and then plus 6. Okay, so what is a 2 squared? 2 squared is 4, so we have 2/3 multiplied by 4, or 4 over 1. 3 times 2 is 6, plus 6. So 2/3 times 4, that's going to be 8/3. And then minus 6 plus 6, which would cancel each other out. And so we're going to end up with 8/3 for our y value here, also known as 2 2/3 as an improper fraction. So for a y value, we're going to have 2 2/3 for 2, and that's going to be the same over here when x is 2 1/2. Okay, plotting that point, let's go 2 and then 2 2/3. That's going to be slightly higher here, so it's going to be not too far away. Okay, and if you didn't want to pick dots that were this close, I totally get it. You can go ahead and choose dots that are further away, but I wanted to kind of pick dots that I knew I could fit onto my graph here. Okay, my rough sketch. Going a little bit further out, let's go maybe, I don't know, I think it's maybe smart to go 2 smaller and then maybe 2 bigger, so let's go 4 1/2. And again, what the reason is, I think 0 is a nice one just because it'll give us our y-intercept, and that's actually a lot less work to do. So if we do f of 0, that should be our y-intercept, right? So f of 0 is going to be 2/3 multiplied by 0 squared minus 3 times 0 plus 6. And then everything's going to cancel out. So we're going to get 0 minus 0 plus 6, or just getting 6. So when x is 0, y is 6, that's also our c value from our a, b, c in the beginning. And so 0, 6, let's go 4, let's go up here to 5, let's go up here to 6. And so we can plug this in and plot it. So 0, 6 is somewhere here, and then 4 1/2. I should draw another line over here to show where 5 is, so we know where 4 1/2 is. So for 4 1/2, 6, I think that's like roughly up here. I'm kind of just eyeballing it. I don't have graph paper, so please forgive me if it's a little off. and then draw a parabola through as many of these as you can so that you can go through each of these points. Okay, so something along the lines, I don't know what's easier, doing this freehand or trying to get this to line up. So maybe this makes sense. Yikes. All right, it's not gonna be perfect. I apologize. Maybe it was just off. All right, I think you get the point. But here would be my parabola. I think it's just maybe a little bit not drawn to scale. So that's as close as I can kind of get it. Maybe I can finagle this by moving this over a little bit and pretend that is more accurate. Okay, let's move on to another one. And hopefully you're getting the hang of this as we practice a little bit more. So for number 5, we have this f of x equals negative 3/4 x squared minus 4x minus 1. So we know a here is going to be negative 3/4 right off the bat. B is going to be negative 4, and then C is going to equal negative 1, or our y-intercept. Okay, let's start with our AOS. Our AOS is going to be equal to x equals negative b over this 2 times whatever a is. And so let's see. X equals negative b would be negative 4, which is positive 4, over 2a, that's going to be 2 multiplied by this negative 3/4. So I'm going to write that there. And that's going to cancel out a little bit. So 2 times negative 3 over 4 is just going to be negative 3 over 2. So let's see, this is going to be 4 over 1 divided by negative 3 over 2, or times negative 2 over 3. If we go ahead and multiply by the reciprocal. And so I think we're going to get negative 8/3. So for the AOS here, I'm thinking x is equal to negative 2 2/3. Now, if you need to pause the video at all to try to work that, the process out, see if that makes sense, then go ahead and see if you can get the same value. So x equals negative 2 2/3 here. Now to find the vertex, we're going to go ahead and use this negative 2 2/3 as our x value. I'm going to use the improper fraction version instead, just because I know I'm going to have to, do some operations, and it's easier to use improper fractions. So let's do f of this negative 8/3 and see what's going to happen. So that's going to be negative 3/4 multiplied by this negative 8 over 3 squared minus 4 over 1, that's 4 multiplied by negative 8/3 minus 1. Okay, so again, this one's not the cleanest looking one, but hopefully we can work through this one together. And negative 8 over 3 squared, that's going to be positive 64 over 9. And then multiplying a negative times a negative is a positive here, so 8 times 4 is going to be 32 over 3. And then minus, let's just write 1 as 1 over 1, just so we're prepared to get common denominators. Here we're going to cancel the 3 and 9 to make 1 and 3. And then 4 and 64, we can make 1 and 16. All right, so this is going to simplify down into being negative 16 over 3 plus this 32 over 3, and taking away 3 over 3, just rewriting everything with the common denominators. Negative 16 plus 32 is going to be positive 16. Minus 3 is going to be 13, so this is going to end up being 13 over 3, which is equal to 4 1/3. So that's going to be the y value over here, 4 1/3. So hopefully that's our vertex, okay? And let's go ahead and use that and start sketching our graph here. So plotting our vertex down, let's go ahead and see if we can go 1, 2, 3 in this left direction, and then we can go up 5 just so we have enough space for the 4 1/3. So 1, 2, 3, 4, and then 5. So now I think that's going to be enough to plot our vertex with enough space there. So negative 2 2/3 is almost negative 3, and then 4 1/3 is going to be closer to 4 than to 5. So I'm going to go ahead and put my vertex somewhere around here. I think that's a pretty good estimate. Okay. So that's going to be the vertex, and then our AOS is going to be going through that. So let's go ahead and try and draw a vertical line. Well, that looks pretty good. And so I think this would be our AOS, right around negative 2 2/3. Actually, maybe I can move this over to the left a little bit. okay? And then I think we can go ahead and use that for our center point, and now just pick some values around it, okay? I'm gonna go ahead and choose, if we choose -1, all right, that's going to be bigger than it. If we choose -1, so what is that? That is technically going to be 1 2/3 more. So if we go 1 2/3 smaller, I think that's going to be -4 1/3. Okay, so I think that is going to be 1 2/3 smaller than that. Okay, let's use the -1 instead of the -4 1/3 though. So plugging in x equals -1, let's do f of -1. That's going to be -3/4 multiplied by this -1 squared minus 4 times -1 minus 1. So -1 squared is going to be 1 times -3/4 is still -3/4. -4 times -1 is +4, so it's going to be +4. I'm going to write that as 4 over 1 because I think we'll need common denominators. And take away 1, which is the same thing as taking away 1 over 1, all right? Now getting common denominators, that's going to be -3/4, and then plus 4 wholes is going to be 16/4, and take away 1 whole is going to be 4/4. So -3 plus 16 is going to be 13, and then 13 take away 4 is going to be 9. So I think this is going to be 9 over 4, aka 2 1/4. So I think that's going to be the y value, 2 1/4 and 2 1/4. Looking at this on the graph, -4 1/3, so we have -3, -4 maybe somewhere around here, and then -5 is over here. So just doing some approximations here. And then let's see, we have to go up to 2 1/4. I think we have enough space for that already. So -4 1/3, comma 2 1/4, 2 1/4. I'm thinking maybe it's somewhere around here. And then for -1, we have 2 1/4. So I think that is located right around here. Okay, so we have those 2 points down. And then finally, I'm just going to choose 2 numbers I think are even easier. So let's go 1 higher like 0 and 1 smaller like -5 1/3. Okay, this should be a lot easier. I'm actually not going to do the work for it because remember, if x is 0, then c should be the y value. So we can go ahead and take that -1 from knowing a, b, and c. I think we've done enough algebra here and to figure out what are each of these values. So hopefully that makes sense, that it can save you some work as well. Let's go with 0, -1. 0, -1. I think that I'm going to go ahead and plot -1 here. So 0, -1 located here, and then -5 1/3. I'll draw one more line here to make -6. And so if we know 0, -1, then this -5 1/3, -1 should be somewhere around here. Okay, so there are 5 dots here, and it's upside down just because we have a -a value. Whenever we have a -a value, then the parabola is upside down. Roughly speaking, our graph would look something like this. So try to line it up and go ahead and put some arrows on there. And so here is our parabola. Number 6. All right, so for number 6, we have f of x is equal to -x² minus 2x minus 1. And if you've been feeling like the last few have been pretty challenging with the fractions, it's because they were. They were a little bit messy. This one hopefully is going to be a little bit cleaner without the fractions, but it's better to maybe try some more annoying looking ones together here than maybe never seeing them and then on a test or something you have to deal with them. So hopefully it's been some good practice regardless of them being a little bit much. Let's start with the AOS here. AOS is going to be, do you know it? It's going to be x equals -b over 2a. And then so if we go ahead and plug some stuff in here, -b is going to be -2, which is +2. And then 2 times a is going to be 2 times -1. And so 2 over -2 is going to simplify down to being just -1. Let me fix that. And so x equals -1 should be our AOS. Okay, we can go ahead and then use that to find out the vertex. So let's go ahead and find f of this -1. So f of -1 is going to be -1 squared minus 2 times -1 minus 1. And so -1 squared is 1, and then throw on the negative. -2 times -1 is +2, and then take away 1. So -1 plus 2 is 1 minus 1 is 0. Okay, interesting. So -1 comma 0 is going to be our vertex. Okay, so let's go ahead and start graphing this a little bit and then go from there. All right, so here is our X and our Y axis, and we can go ahead and start plotting where our vertex would be here as well. Notice that we have another negative A value, so we're gonna end up being flipping this whole thing down again, just like in the last example. So we can go ahead and put our vertex right here at -1, 0, okay? Let's go ahead and pick some numbers that are around this. So let's say X is -2. Let's go one smaller and one bigger. Actually, if X is 0, then we know Y. Isn't it the C value? So that should be -1, and this should also be -1. So look at that. This actually is much nicer than the last couple already for that reason. And so let's go ahead and make this -2, and let's plot this as a -1. And so -2, -1 would be right around here, and 0, -1 is right over here. So we already got 3 points, and we didn't even have to do that much work. For the last one, let's do X equals +1, and let's do -3, okay? And let's go ahead, I'm gonna use the +1 here. So I'm gonna do f of +1, and that's gonna be -1 squared minus 2 times the 1 minus 1. And so 1 squared is 1, it's a -1, and then 2 times 1 is 2, minus 1. So -1 minus 2 is -3. Take away 1 is -4. So I think we're going to get -4 over here, which will be the same for when x is -3. All right, so we need just a couple more numbers on here. So +1s over here. I think we need to go over to -3 along the x-axis here and go down to -4 at least. So -1, -2, -3, and -4. So -3, -4 looks like that will be somewhere around here, and +1, 4 would be over here to the right. I forgot to draw my AOS, so sorry about that. If you were concerned, here it is. Have no fear. There's the AOS, so you can hopefully see the symmetry. And then let's go ahead and sketch the parabola. Maybe something like this. And the vertex is here. It's close enough. I'm okay with this. All right, cool. So there's our parabola. Let's check out number 7. For number 7, we have this f of x is equal to 2x squared plus 8x plus 3. And so let's give this one a go. A here is going to equal 2, B is going to equal 8, and then C is going to equal 3. All right, let's start with the AOS. So the AOS, let's see if you remember it. X equals -b over 2 times whatever A is. And so x equals -b, which is going to be -8, over 2 times A, which is 2 times 2. So it's going to be -8 over 4. So x equals -2 for the AOS. Now that we know that the AOS is at x equals -2, we can find the vertex. So f of -2 is going to equal 2 times this -2 squared plus 8 times the -2 plus 3. Okay, this -2 squared is going to be 4, and 4 times 2 is going to be 8. And then this 8 times -2 is -16, so it's 8 minus 16 plus this 3. And so 8 minus 16 is -8, plus the 3 is going to be this -5. So when x is -2, y is going to be -5, and that's the vertex. Let's go ahead and start sketching the graph here. All right, so here is our xy graph. -2 is going to be 2 in the direction over here. And for our y-axis, it's going to go -1, -2, -3, -4, and -5. So down here, y is -5. And we know that's the lowest point we need to go because A is positive, so we're going to have a minimum here. Our AOS is that vertical line at x equals -2, so let's go ahead and sketch that in as well. So I'm going to move that over slightly to the right. I think that's a little bit better. And so here is our AOS. And then we're going to go ahead and plot this -5 on there. So right about there should be our vertex. Okay, let's go ahead and see if we can find out some other values here. What I'm going to do is let's go with -1. So let's go -1, which is a little bit bigger, and we'll go with -3, which is a little smaller. And let's start with the, I'll use the -1. Okay, so for -1, let's do f of -1. And that's going to end up being 2 times the -1 squared plus 8 times the -1 plus 3. Okay, and so negative 1 squared is going to be 1 times 2 is 2. 8 times negative 1 is going to be negative 8, and then plus the 3. 2 minus the 8 is going to be negative 6. Negative 6 plus 3 is going to be negative 3. So when x is negative 1, y is negative 3. And so when x is negative 3, y is also negative 3. Plotting this on the graph here is that negative 3. So we also have negative 1, negative 2, negative 3 in the y direction. So plotting these points here, negative 3, negative 3, I think that's going to be somewhere right around here. And then if we plot the negative 1, negative 3, that's going to be right around here. Okay. Next, we're going to go with x being 0. Again, we like that because you're going to see what happens. If x is 0, then we get c for the y value, which is positive 3. And so we can go ahead and do that without getting any more extra work that we have to add in there. Okay, so let's go ahead and plot this 0, 3, 1, 2, 3. Looks pretty accurate. And then here's 0, 3, and then negative 4, 3. You have to go over to the left a little bit more. Here's negative 4, and so negative 4, 3, somewhere up here. And then let's try to sketch a rough parabola. So something along the lines of this maybe. I think that's close enough. I think you get the point. Obviously, I have a little bit of advantage over you, but try to sketch it the best you possibly can. Okay. Final one, number 8. For number 8, we have f of x is equal to negative 1/4 x squared plus 3x minus 2. So let's go ahead and identify some stuff here. So if you've made it this far, you've been doing fantastic. These are not the easiest things in the world, but they're also not terribly difficult once you get the hang of it, right? They all have kind of a similar pattern. You just kind of have to get used to how they are laid out, and they start to get a little bit easier as you go, as with anything. So for the AOS here, you have x is equal to negative b divided by 2a. And so let's say x is equal to negative 3 on top of 2 times a, so it's going to be 2 times negative 1/4. So if you double a quarter, that's going to be a half, so that's negative 3 over negative a half. And if you divide, you end up multiplying by the reciprocal, so it's negative 3 times negative 2, so x is going to equal positive 6. So our AOS is going to be located here at x equals 6, and we can go ahead and find the vertex now. So let's go and find f of 6. F of 6 is going to be negative 1/4 multiplied by this 6 squared plus 3 times 6, and then minus 2. So 6 squared is 36. We have negative 1/4 of 36. I think we're going to have some nice cross canceling. 3 times 6 is 18 minus 2. And so 4 and 36, if 4 goes into 36 9 times, so we're going to end up with negative 9 plus 18 minus 2. So negative 9 plus 18 is 9, and 9 minus 2 is going to be 7. So when x is 6, y is going to be 7. So that's our vertex, all right? And we can go ahead and start graphing. And we'll start with our AOS, which is going to have an x value of 6. So 1, 2, 3, 4, 5, 6, and I'll keep going. 7, 8, 9. But let's go with 6, 1, 2, 3, 4, 5, 6. That's going to be right in the middle. And we went more to the right just because the 6 is in the middle. So we're going to have stuff on both sides of it. So here is our AOS. Let me move it over slightly to the right. Cool. So that's going to be where the middle of our parabola is going to be located. And we have to go up 7 units here. So let's go up 1, 2, 3, 4, 5, 6, and 7. And keep in mind that we don't have to go any higher than this at any point just because a is negative, so it's going to be flipped upside down. So this right here is going to be the highest point of our parabola. All right, it's never going to go any higher. It's going to go lower from here. All right. So maybe going ahead here, I can go. I kind of want to choose some even numbers just because I'd like some stuff to cancel out. So I'm going to go with 4 and 8 here, okay? And I might not be able to fit everything in, but I will do my best. I think we can fit these two on here at least. So let's go with 4. And if we do 4, let's do f of 4. So f of 4 will be equal to -1/4 multiplied by 4 squared. Again, if you chose 5, you'd have 5 squared, and that would be kind of annoying, right? So try to be strategic to save yourself some work. Times 3, this is 3 times 4, and then take away 2. So 4 squared is 16, and 1/4 of 16 is going to be 4, but it's negative, so it's -4 plus 3 times 4 is going to be 12 minus 2. -4 plus 12 is 8, minus 2 is going to be 6. So 8, 6 and 4, 6 are going to be 2 more points on this graph. So 4, 6 looks like it's going to be right around here, I think. And then 8, 6 I think is right around here. All right, now if you go any further out, I'm gonna run out of space here, but I'm just gonna show you, like, what if we say x was going to be smaller, like 0. I'll make x 0, and then that's gonna be 4 smaller, so this would be 12, right? So I can't really go in that direction, but I'm doing this just because we know c is -2, so this would be -2, and this would be -2. So maybe I'll plot one of these, but not the other. So I have space on here to plot 0, -2, so that'll be over here, and just imagine there would be another dot over to the right. I'm just not able to sketch it. Our problem will look something like this. All right, so I know it's a little cut off, but that'll do. So there you have 8 different practice problems on graphing quadratic functions or quadratic equations when they're written in standard form. I know some of these were a little bit trickier than others, but I wanted to give you a comprehensive review or practice session on these ones where you can deal with these fractions. And if you can deal with these fractions, you can pretty much deal with any one that will be thrown at you. So this is graphing them by hand. Obviously, if you have a graphing calculator or Desmos or something like that, it's going to be quite a bit easier to find these things. But if you have to do this by hand without a calculator, hopefully this was helpful. So as always, keep up the great work that you're already doing, and I will see you in the next one.